Good afternoon, ladies and gentlemen, and welcome to room 10 Pasteur. Good to see you all after a hopefully relaxing lunch break. I hope you're not too relaxed for this session now, because for the next hour we want to take a close look at the EU space program for you. And I would like to stress for you, because hopefully you will also use this hour, not just get information from the experts here in the front, but also to use the opportunity to pick their brains afterwards so that you can get all the information, all the input that is important for you, important takeaways, how you can benefit from the EU space program and all the various aspects. And in order to get your input, for one, we have Slido, like everyone else here. Just a show of hands, anyone who hasn't downloaded the app yet? Okay, 1, 2, 3, 4. Now would be a good time to do it, because it's not just that it enables you to submit questions, though this is a very small room, it's a very intimate feel, and of course you can also just ask your questions. I will be able to provide you with a microphone so that we can hear your questions. But if you prefer to submit them via Slido, that would be an option. Slido is also important because we would like to gauge your mood or your views on certain aspects by giving you polling questions, multiple choice and word cloud questions, and that I'm afraid you can only do if you use Slido. So please do make sure that you've got it downloaded and then click onto the right room, which is 10 Pasteur, and then you're part and parcel of this session. Let's get it underway right now, because time is of the essence, as so often, with only 1 hour. And the official welcome speech, for that we will welcome now the head of Unit GROW, J1 Galileo and EGNOS Program Management and GNSS Policy. Monsieur Paul Flamand, welcome.
Thank you, Monica. Welcome everybody in this room, which unfortunately is the Pasteur room and not the Galileo or Copernicus room. I don't know what the organizer did, but that's the wrong place. We are not in the right place here. So I want to, yes, I will raise a complaint on that. I want to address the importance of research and innovation for all what we do. And I think that research and innovation starts in your brain thanks to inspiration. And I wanted to start this speech with something which dates back 50 years ago. Some of you were maybe not born, but 50 years ago, there was a very nice movie called 2001 Space Odyssey of Stanley Kubrick. It got out in 1968 or 69, I think. So really 50 years ago. In that movie, I remember very well, I was quite young, but I remember very well, you had apes and astronauts finding a sort of black stone, a black monolith, a rock, big rock, black big rock. And by touching the rock, they became intelligent. This was an explanation of how humanity became intelligent, how apes became humans. But the funny thing of that rock was that when apes or human beings were touching the rock, it enlightened itself. It became full of colors, full of lights. And I remember that in those days, wow, this is really science fiction. I will never see something like this in my life. If I touch this, it enlightens up. And what was science fiction 50 years ago is not just the reality. And I'm really hoping that all the topics that we are addressing today, which looks like science fiction, will one day become reality, and maybe still within our own lifetime. So, not 50 years ago, but 20 years ago, we started to work in the European Union, in the European Commission, with some other actors, like industry, like European Space Agency, etc. We started to work on two important, what we call flagship programs, Galileo and Copernicus. Copernicus was there to observe the Earth, and Galileo was there to provide positioning information. 20 years later, today, we have Copernicus, 6 services. If you watch Euronews every evening, you see before the Meteo, they are providing information coming from Copernicus. That's nice. Pollution information, wind information. This is something exciting, which we participated in building. Galileo, we announced last week that we now have something like 1 billion equipment users which are using Galileo signals in the mobile phones, in the navigators in the car. So yes, we are there with something that we developed all together. And these projects, they provide data and signals. And thanks to those data and signals, which are provided freely to anybody in Europe and even around the world, we create new businesses. People have ideas and they are able to create businesses through, thanks to that. On the other hand, research funding is being used also to inject new ideas in the evolutions of those programs, whether Galileo, Copernicus, EGNOS, and even some others. And this is pretty important in Europe. Space research is pretty important. We have something like 50,000 people working on those infrastructures, what we call the upstream sector of space. And we have nearly 200,000 people working on what we call the downstream sector, so all the development of applications, new ideas, etc. Space is generating something like 15 billion euro of economic value in Europe every year. Each time we invest 1 euro into space programs, the fallback is something like 4, 5, 6 euros. So it's a good investment rate. It's a good return on our investment. So what do we have in front of us in a nutshell? Now, with the new financial framework, 2021-2027, we have a single space program. A single space program in one regulation, where we combine everything, Galileo, Copernicus, EGNOS, and some others. And we want to put those infrastructure at the disposal of the digital world, for Internet of Things, for 5G, etc. And that is the single space program. And then we have Horizon Europe, and we want to make sure that Horizon Europe is being used in a way that it serves the best possible this single space program. So therefore, Horizon Europe will help us to support competitiveness, to increase or to make more easy for companies to access to space, not simply in terms of launching, but really to access the data coming from space. And we want to reinforce the startups in Europe. We want to increase their numbers. We want to increase the success rate. We want to make it easier for those startups to scale up, to really become big companies in Europe and in the world. Where do we stand with that? We are now talking with the stakeholders, and therefore we have consultation platforms where we try to gather all the information, all the brilliant ideas that will structure our future in 20 years and in 50 years. And so now to finalize this talk, you're going to ask me, yes, this is all nice, but what kind of money do we have for all that? Too early to say, unfortunately. In Horizon Europe, there is a cluster. It's a big bag where you put a lot of things called digital, industry, and space. What is the amount of money in that cluster that will be devoted to space? Frankly speaking, I don't know. We have our hopes for several billion euros, but it's again a question of negotiation between Council, Parliament, the services of the Commission, etc. So we will see that, and I think that later on there will be a session this afternoon on that particular cluster. So maybe you can get some clues of what it will be in terms of funding. I think that's it. In terms of inspiration, after 2001 Space Odyssey, there is maybe one more thing I wanted to add, which is quantum physics. You know quantum physics? This is marvelous. You all use that in your computers through the transistors, through the tunnel effect, for example. It is quantum physics. Quantum physics today is allowing a lot of marvelous things. New types of computers, new types of communication that will be very robust, etc. It's maybe a topic for research, which I would certainly invite you to consider, because I'm convinced that this will change the world. That's it, Monica.
Thank you. Clement. And I just want to make one sort of observation, a beautiful link to the 2001 Space Odyssey movie, and the rock that starts to light when apes touch it. It also made them intelligent. We're not there yet with the mobile phone, but maybe that's part of the next EU space program. Maybe we can work on that as well. And of course, you'll be on your way to Ostend very soon, where we meet tomorrow for one of the big services, the Galileo Search and Rescue Service, which will be a live demonstration to show that it makes a rescue operation on the high seas, in that case the North Sea, so much faster than as it is now up until this point. So that is something to look forward to. But we're still here in room 10 Pasteur at the RNI Days in Brussels, and I have a wonderful panel. I would like to introduce them to you now, and they'll take their seat. You still have a choice where you would like to sit. There is no specific order. We welcome Cristina Ananasso. She is European Commission Copernicus Program Officer, EU Policies Copernicus expert. Good to have you with us. And whenever you feel like applauding, especially after lunch, please feel free to do so. We also say hello to Jérémy Godet, European Commission Galileo Deputy Head of Unit, Dr. Bojan Boškov, Head of the Remote Sensing and Products Division and the Department of Technical Support and Science at EUMETSAT, and last but not least, Dr. Guglielmo Alietti from the University of Surrey. So before they start presenting their expertise to you, now is the time for you to get your devices out and use Slido for a multiple choice polling question that I would like to put to you. And as in a moment you will be able to see it, the question would be, which of these applications do not use in any way space services or data? You can choose between Pokemon Go, Instagram, Triposo, or none of the above. I don't think that all of you have already chosen Pokemon Go, have you? Have you all already taken part in this multiple choice? The polling is closed. That sort of defeats the object. Can we change that? Is it open now? It's open now. Okay, then let's see what you decide. Okay, which of these applications do not use in any way space services or data? Okay, that certainly looks more like it. Okay, I think I can. No? Okay, well, at least all of the possibilities did get some votes. But the majority of you here in the room got it right. It is indeed none of the above. So they all use it, which shouldn't come as a surprise when I look at the panel. So we have a savvy audience in here. I didn't expect anything less from you. So let's get started with the first of the two EU flagship programs that Paul mentioned already. Copernicus we're starting with. And of course, that is the program that is monitoring the Earth's environment, collecting tons and tons and tons of data, and all of that is open to all and free of charge. I remember last year I did a panel in the European Parliament on Copernicus, and back then it said tens of thousands of users make use of it. I should think that by now the number is probably slightly higher. Let's find out a little bit more about this now, and welcome again Cristina Ananasso, EU Commission Copernicus Program Officer, and here is your pointer.
Good afternoon to everybody. I'm very pleased to be here representing Copernicus. So what is Copernicus? Copernicus was born as a tool to monitor the environment and also as the European Union contribution to global environment and climate change effort, in particular dealing with international commitments such as COP21. The core of the program are the 6 services. Climate change, land, water, ocean and atmosphere monitoring, security and emergency management. All of these services are using space data, Earth observation data coming from Sentinel and contributing mission, in situ data and models. And these services are already delivering, using all this data, added value products. All this data, as already Monica said, are open, full, free, and accessible. This is only one example of, I think, a perfect example for the combination of this kind of, no, sorry, I have to, okay. There should be a slide motion where in this kind is a perfect example of a combination of these different kind of data, space, in situ, and models, showing a pollutant, in this case nitrogen dioxide, spreading over Europe. Another example is coming from the climate change services. In this case, the climate services is producing a huge amount of climate indicators. And these data, this information, are already made available to the EGNOS context. As was already said, in the last years, the Commission is working on the future of this program. The evolution is based on a policy context, a twofold policy context. The first one is the European Union Space Programme Regulation, and put together all the different space programs in only one single program, and with three main objectives. Continuity, there will be a strong investment in the already existing services. The evolution to match new and emerging needs, climate change, Arctic, sustainable development, and to adapt to new realities, in particular the new space or new geopolitical realities. Then the second policy context is more recent and is the European Green Deal that is part of the mission of the new Commission. In the mission letter for Sylvie Goulard, that is the Commissioner designated for Internal Market, Copernicus is explicitly mentioned as a tool to monitor CO2 emission. But this is not really new for us, because we are already working on the CO2 program, not only on the CO2 emission, not only from the Copernicus side, but also in Horizon 2020. In fact, we have already this project ongoing, the CHE project, CO2 human emission, that is a preparatory project for the Copernicus CO2 emission monitoring capacity that should be ready, and when I say ready, it means operationally ready for 2026. Also here I have, okay, this is a nice simulation from this project, and with this slide I can conclude my presentation. Thank you.
Thank you. So we have time for one or two follow-up questions. If you have one immediately, the easiest would be to raise your hand. There is a gentleman at the very end.
Thank you, Mr. Chair. Good evening, citizens. Angelos Harlaftis, Epafos Advisors. We represent here Urania and Helios space and defense communities in Europe. And I'm a member also of the Copernicus communities, and I have posed 2 times the question, isn't the time come for the Copernicus to get some money from the foreigners? Foreigners meant the outside of European lands and Mediterranean, because we have to invest in the new technologies, and the times are hard. Apart from that, it's the taxpayers' money, and they need a kind of, to come some money back to be reinvested instead of taking from the national state of the member states, which they have facing difficulties. Thank you.
Thank you. Would you like to answer straight away?
It's a very tough question, this one. I don't think that I have the real and the concrete answer to this. I don't know if Paul Flamand can support me on this.
Okay, it is a tough question. Nevertheless, it is a justified question, a good question, and everybody heard it. If we don't have anyone right now here feeling comfortable with giving a straightaway answer, then we just have to leave it at that. But thank you very much for the question anyhow. There was a gentleman here in the front.
Mamun Gagulava from Georgia. I'm correspondent member for GEO. I have a question regarding the climate service.
Yes.
Do you want to make it a layman, the easy, the user-friendly? Because it's really difficult, and the public support for climate change, combating the climate change, is really important. People should see what is changing, but even for the scientists, it's quite difficult to get and process information. Do you have plans to make it really user-friendly so that it can be used by non-scientists?
Yes, for sure, this is one of our internal Copernicus mission, and it's not only for the climate service, but it's for all the services that are already developed. For each of these services, we have a service desk that, at least for our knowledge, work very close to the user. The user can be a small or medium enterprise that want to make a market, do business with the data, or also with the single citizen that want to access data. As we know, they are working really well with this service desk tool, and if not, please let us know, because this is a concrete problem, and we should resolve it when it's there. Thank you for your question.
Thank you, Christina, for the presentation and also for taking some tough questions. We'll have more questions for you and the rest of the panelists later on, but first let's move on to our next EU flagship program, and of course is Galileo, Global Navigation Satellite System, which was created by the European Union, and indeed it is a European achievement. It didn't come overnight. It had to take some hurdles on the way, but eventually we got there in December 2016. Perhaps you remember Galileo moved from the testing phase to operational services, and since then it's been making quite a difference for mass market uses, for utilities and financial transactions, for people lost at sea, I mentioned that earlier, or in the mountains with the search and rescue service. And there is much more to come. And we will hear much more about Galileo now from Jérémy Godet, Deputy Head of Unit GROW J1 Galileo.
Thank you. Thank you, Monica. And good afternoon to all. So indeed, 20 years ago, Europe was 30 years behind in the field of satellite navigation. 20 years ago, there were application of GPS blooming on military and civilian sides. GPS started in 1970 and became operational in 1995. And 20 years ago, Europe had no practical implementation experience of satellite navigation. We never flew a satellite in the Middle Earth orbit. We never flew an atomic clock in space. But there was quite some considerable knowledge in the member states, in the research organization, universities, space agencies. So in 1995, the EU and Eurocontrol and ESA, they stepped up to build a satellite-based augmentation system called EGNOS to be able to use GPS for aviation over Europe. And also, 20 years ago, the EU and ESA started the definition phase of the Galileo program. This was the beginning of the largest European space program. And 20 years later, today, Europe has two satellite navigation systems in place. EGNOS, which is operational since 2011, makes plane landing safely in more than 250 airports in Europe. And Galileo was 26 satellites and started its services in late 2016. Monica, you will remember that. And it has, in less than 3 years, reached 1 billion users. This is quite an achievement. I don't know if you know how many years it took for Facebook to get 1 billion users. Anybody knows? 8 years and a half. So I think we can be proud of it. The role of the EU, it could not have happened without the determination of all the commissioners in charge of this program. And I would like to emphasize the role of two of them, who are unfortunately not with us anymore. Loyola de Palacio, who never stopped to demonstrate the importance, strategic importance and economic importance for Europe to have a satellite navigation system of its own in front of sometimes unconvinced transport ministers, but she never gave up. Jacques Barrot, who managed to find 3 billion euros in the middle of the financial perspective from his fellow commissioners. And this was to finalize the deployment of Galileo at a moment when it became apparent that the concession model for public-private partnership would not work. So 20 years ago, we were 30 years behind. But actually, that was also a competitive advantage, because GPS design was already 30 years old. So Galileo could start from a blank sheet of paper using the most up-to-date innovation and technologies. For instance, the most accurate atomic clocks ever flown in space, the largest ground monitoring network and the fastest uplink capabilities, combined with very complex algorithms. The most performing satellite navigation signals that actually led to some innovation award, European Innovation Award in 2017. And basically all that led to a system which is today the most accurate satellite navigation system in the world. It's about 4 times more accurate than GPS. This is what we measure today. So we can also be proud of this. So to maintain the Galileo competitiveness and to continue this fast market adoption trend, we will need to continue to use research and innovation. This is absolutely key. For the upstream, we will shift from service preparation, technology and equipment development, as we did in Horizon 2020, to in-orbit demonstration, test beds, and also measures to improve the autonomy of the industrial supply chain. On the downstream, we'll move from application to basically making Galileo a leader where the differentiators of Galileo makes a difference. And also we'll support the EU industry to be able to export that additional knowledge created. We'll use new instruments, pre-commercial procurement, public procurement of innovative solutions. We will have solutions to help the startups, and we will improve the synergy with Copernicus and other space programs. So overall, we consider that a strong increase in terms of investment is needed for Horizon Europe compared to the 450 million euro approximately that were baseline for Horizon 2020. That's my presentation.
Thank you. Thank you, Jeremy. So we heard already from Paul Flamand earlier that it's too early to talk about money, but you just sort of certainly mentioned, you just threw a figure here into the room, and so the sky is the limit. Any immediate questions, short and precise? There is a gentleman.
Thank you for the presentation. I would like to take the last point, which you said that there are going to be more collaboration between Galileo and Copernicus. Can you be more concrete on this and what this collaboration would mean? Thank you.
Yeah, I would rather use the word synergies. For instance, in the field of research, there are many complementary solutions. I'm thinking, for instance, it's clear that on climate change and the study of the soil, the resource, there was a project which uses the reflectometry of the satellite navigation signal on the soil, and would put a signature of the humidity of the soil. So agriculture could know where to put water and save basically water. This, in addition with Copernicus images on the land use, is combined to make basically a more optimal use of the land resources, as an example.
Maybe.
Yes, please.
Concretely, we are going.
We need the microphone for Christina.
If I can add something, concretely, we are also promoting some kind of topics in the Copernicus domain, where the synergies and the link with Galileo is very important. and in the future, probably for Horizon Europe, also activities related to accelerator and real downstream application can be done together.
Okay, well, thank you very much. And don't you worry, we've got plenty of time after all the presentations for more questions. Let's just move on to two stakeholders when it comes to the EU space program for you. And we move on to EUMETSAT, the European Organization for the Exploitation of Meteorological Satellites, which of course is an intergovernmental organization that was created to supply weather and climate-related satellite data, images, products 24/7, 365 days a year to the national meteorological services of all the member states in Europe and beyond. And Dr. Bojan Boškov can tell us much more about it. Over to you.
Well, thank you very much for the kind introduction. Yes, we are a service organization that happens to fly satellite instruments. And we've been doing it successfully for about 35 years. We're currently in the second generation of satellite systems that provide 24/7 key data for weather prediction. Essentially what you see on applications such as Windy or in Germany, Warnwetter, or any type of such application, often the data originates at us before it goes into the weather modeling of Météo France, UK Met Office, ECMWF. We are really service-oriented. This is our big thing. In a way, I sometimes sarcastically say we are maybe a precursor to Copernicus, but I say it among scientists. But really what we do is very clear. We know who our users are. Our users are the weather services. It's the citizen who wants to know if they can go to the beach tomorrow. And this is actually quite an important thing for us to do economically and the impact on this. We also have programs that last a long time. Our third generation geostationary will be operating for at least 20 years. It will be starting to fly in about 3 years. And this is something that is really important. We actually commit long term. Our member states commit to this. A program, a fleet does not happen before we actually get everybody on board agreeing to do this. Of course, this is really good for the scientific community because it gives perspective. Horizon Europe will benefit from this because any investment today that you do into new applications, new things that are not necessarily weather-related, it could be other things which I'll show later. This is an investment where also applications could be used in 20 or even 30 years in some cases. The one thing is what we put a lot of effort in before actually proposing the programs to our member states is to really ensure that what is put on the platforms is actually leading edge and will still be relevant in 20 years. So at times, we sometimes are seen as being a bit adventurous because certain instruments or certain things that we plan for are not fully mature in the sense that is making conservative people comfortable. But science is something that grows. Science is something that needs challenges to advance. And what we have in our case is that on EPSSG or MTG are instruments that still need a lot of work to actually have a full understanding, not just for the weather applications, but also in the other applications that are related to this. And this is really offering a lot of opportunity to Horizon Europe in the future. The other thing, where do I click, in which direction, sorry? Here. So the other thing is, and this is just an example, as the technology has evolved in the last 2-3 decades, really in the heyday of Earth observation, the combination of our platforms and the instrumentations of our platform will come to what we like to call the 4D weather cube. But when you look at the breakdown of the 4D weather cube, which in the case of our third generation geostationary satellite will be, it actually breaks down in very many interesting different elements. You will be able with the instrumentation that is there to look at surface properties, looking at what is the temperature on land, what is the vegetation on land. Yes, it is not the resolution of something that you could tell you what is your garden, but you're looking at measurements of 0.5 kilometer every 10 minutes for all of the disk, including Africa, Europe, and the Near East. It is really something that will change some of the analysis and will be of great benefit, not just to meteorology, not just to services, but also to overall services in other areas, things that we still don't know. But all of this work requires research, feedback, and operations. And really, this is how I like to end on this brief introduction of EUMETSAT and our goals and our impacts, is that we can do good operations without research. But because of the operational mandates, the long-term missions that exist and are committed to till 2040s, there is the feedback mechanism. And that feedback will require research, which will bring back innovation to operational systems, such as for meteorology or other applications that are still to be found out. Thank you.
Thank you. Thank you. And obviously, because of what you just said at the end, that you really need the input also of the scientists, is that the reason why EUMETSAT is proposing a full and free open data policy, that the scientists can use the data, just like that?
Yes, actually, it is going back to the philosophy that many of us who work in Earth observation, the more you look at the data, the more eyes look at the data, the better the data becomes for what you need to use it for. So we really welcome this. The data is free for researchers. It is free for Horizon Europe. If you have questions or anything like that, contact us.
Do you have a follow-up question straight away? There is a gentleman. Which microphone is faster? I think the one from behind.
We quite hear a lot of data, services, and so on. And you indicated the next generation of satellites, maybe. So what type of technology is needed on the satellite and on the launching systems, which is then enabling these services? I didn't hear anything about that.
Okay. Well, the launching services in Europe, I say there's no real competition. I mean, okay, in the sense we are as good as everybody else, in some cases even better. To say we are more reliable than our American colleagues or Russian colleagues. So I think on the launching side, things are good. With respect to the technology that is being used, well, I mean, it's leading edge European technology that is being implemented. We are looking, of course, at, trying to take advantages of the minimization, not minimization, how do you say this now? Well, you know what I'm talking about, but of technology, and also taking advantage of increased IT capability that you can have on the platform. For example, in the case of our hyperspectral infrared sounders, they measure every second 25,600 spectra of 8,000 channels at the time. So you need to have onboard compression to be able to transmit this effectively down to the ground. So it's really pushing, in cooperation, of course, with the European Space Agency and European industry, the envelope on this. And we are really, in many cases, unrivaled on what is going to fly on MTG or EPSSG.
And Bojan just had a very interesting chart also, I think it was the second to the last, that showed a whole raft of satellites from the METOP series to the Jason family, the Sentinel, and I was fortunate enough to be part of a lot of those launch events, which makes me aware, of course, that over the years it's gotten somewhat crowded up there in orbit. I sometimes sort of try and imagine it, all the satellites like motorway during rush hour. And that's fine as long as they're well coordinated. But as we all know, when we drive on a motorway, there are sometimes vehicles who break down. And what do you do with those? They are getting in the way. And that brings us straight to Dr. Guglielmo Alietti from the University of Surrey, because space debris removal is an opportunity and a challenge.
Yes, thanks for the kind introduction. This was actually a project that was funded by the European Commission, and what I have for you are a couple of videos that explain what the problem is and what our mission was in order to tackle this problem. And again, some technologies that we have demonstrated. So
in a world reliant on mobile phones, communications such as the internet, and electronic monitoring systems, satellite technology is crucial to our modern way of life. Perhaps unsurprisingly, with ever more demand for services, more and more satellites have been popping up in orbit around the Earth. But this has led to a problem. There's now lots of junk in space. This space junk comes in all shapes and sizes, from the tiniest fleck of paint right through to dead satellites that no longer work. Scientists have estimated that there's already an incredible 7,000 tons of junk in space, and it's increasing. Satellite collisions have occurred in space. Scientists are now exploring the best ways to minimise and remove space junk in order to combat the problem.
So what are you going to see now is the mission. This is an animation that we did actually before doing the mission itself of the technologies that could be used in order to recover some of these debris. And the first technology is a net that you will see launched in a couple of seconds from this satellite to capture that piece of simulated debris. After I'll show you the picture of actually the real mission, okay? But for the moment, the animation. The second thing that we demonstrated was a way to monitor a piece of debris in order to plan the following capture. Third technology was harpoon, because why not? If you want to capture something in a simple way, maybe just harpooning it and then towing it could be a cheap and cheerful way to succeed. And the final demonstration was something then to deorbit the satellite, so you can deploy the sail, and because we are talking about low Earth orbit and there is some residual atmosphere, this slows down the satellite, so it lowers the orbit, and the satellite then burn into the atmosphere. Okay, so this was the video that we did before actually doing the mission itself, and now I'll show you the bits of the real demonstrations in space. Okay, so the first one is the net demonstration. So this again is still the thing before, and this is the real pictures taken from the satellite. Different cameras to monitor the thing with different qualities. This camera, for example, shows you the distance of the object. The color is proportional to the distance, so you know how far the target is. So this is the first time that an experiment like that was performed in space. As you can see, a bit different from the visualization done before. That's why we do the real experiments, to see how different the models are from the real thing. Then the next is the harpoon. So now you see the real target being deployed. And that little panel, this panel here, is the same material that was used in all the satellites. Big dramatic event. As you can see, the target is tethered with a cable to the main satellite, because otherwise we would have produced even more debris, which would have been a bit embarrassing for this kind of mission. So, and finally, it twisted around.
Space debris has declared its first test a success. Removed debris was launched in June. The project, part funded by the European Community,
part of a project to work out how best to capture space junk that's all removed debris. And
the world's most advanced litter picker has begun.
Auch einen kleinen Satelliten. Remove debris.
Okay, so again, we were very happy with the project, because also the media attention, we in the field, we know about, this kind of problems and so on, but we were happy that all the media picked up on this thing, and so now there is more awareness, and we are doing something actually to resolve, let's say, the problem, because it becomes a real issue, because now, yes, the probability that the new satellite is hit by one of these debris is there, but it's still relatively low. But now is the time to act in order to make sure that the problem doesn't really degenerate. Sorry, why? That's it. So it stayed there. So if there are any questions?
What we've just seen, so this was like a test in space.
Exactly.
So we know this is what it looks like, a bit like Spider-Man.
Well, it was the demonstration of the technologies with some debris that we put there to prove that, let's say, the technology is ready to do it for real. Now the problem is, okay, if we want to do it, clearly we have to scale up the mission, right. But some of the technologies are ready.
And how do you scale it up? Obviously somebody needs to pay for it.
I think that's the first problem. What we have to scale up is the budget as the first thing. And we have to find, if you want, a customer, because we are all stakeholders. We all use, space technologies. But at the end of the day, these kind of missions, we have to make an agreement between, maybe the various institutions, users, various agencies, and so on, to put together the budget that is necessary to go and start to do this cleanup operation before it's too late.
Do we have any volunteers in here? Any possible future customers? No? What happens, we're not stopping launching satellites in orbit. And there's already all that debris out there. And what we right now have is like a pilot project.
Yes, exactly. So as we want to put in orbit, more satellites, because we have seen all the benefits, clearly we have to be a bit more careful. It is necessary to have more coordination between all the various agencies. And in my opinion, again, has really become the moment in which we have to start to take down some of the things that we have put in orbit. We all know that there are guidelines, so every new satellite we put in orbit has to be, let's say, disposed of within 25 years and so on. But these things really, for the moment, are guidelines. They are not really enforced. Maybe, the world community has to be a bit more assertive in trying to make sure, for example, that people follow these things. We are all aware that in the past there have been, experiments with anti-satellites, weapons to demonstrate the capabilities to, shutting down a satellite with a rocket from the ground. That has produced a lot of debris. Those kind of things should be a bit, unacceptable. And hopefully in the future people will, restrain themselves from doing these kind of things.
So we have about 10 minutes for your questions. But before we start, please take your devices out. We would like to show them what you think about which areas or sectors do you believe should be supported under the new R&D programs. And this time it is not a multiple choice. This time you actually have to come up with the answer yourself, type it in, and we will create a word cloud. So if there's a lot of harmony in the room, we will get one big word on the screen. If you all have different ideas, we will get a nice pattern of words, and that allows them to react to it. So if you could answer that question. So 4 people have written something. That's a start. Capacity navigation, building measures. Maybe building capacity. Climate. Here we go. Carbon data, cleaning, reanalysis, soil, prediction, micro launches, monitoring, climate. Okay. There certainly seems to be a major focus on that, which is not surprising, especially not this week. So, Christina, Jeremy, Bojan, Dr. Alietti, if you would like to react, if there's anything that maybe something you miss or something you would like to support, something that fits Copernicus or Galileo or EUMETSAT?
For sure, Copernicus is in charge of all these big 3 or 4 words, and climate is for us one of the main goals since the beginning of the program. And also now that we are working on the evolution of the program, both for the space component but also for the services, the climate and the monitor of CO2, that is an important parameter for climate change, is one of our main tasks. And prediction measures re-enter in I think in the presentation that I have done, putting together space data that are not enough. We need other kind of measurements, in situ measurement, but we need, for climate in particular, but also for other kind of application related to marine monitoring or to atmosphere, models to do reanalysis and to do prediction that is forecast. And it's in line, with the Copernicus program, I think.
Anyone else want to comment, or shall we see what questions we have from the floor? What questions we have from the floor? There's a gentleman there raising his hand, and maybe we can take a look if some questions were submitted using Slido, because they should not be wasted if you taken all the time and effort to write something. And in the meantime, perhaps this is a bit far away for me, so if somebody could hand over the microphone. You've got it already. Off you go.
Thank you. Congratulations for the space debris. It's a thing we are discussing a lot of years. And of course, the upscaling, I don't believe it's in this kind of technology, but it's a very big beginning. And the net, you know that the Japanese are the first who theoretically researched about this. The question is, of course, that we have the nanosatellites now, which they are all around, apart from Europe, of course, or maybe in Europe we are not so strong. And these are bringing more space debris, so the solution must be massive, to not the 7,000 tons, but to more than 7,000. But it's a very big beginning, a very good beginning for us, and it has an advantage, as the lady told, about the industry. We can get money there. The question is on the Galileo. Some months ago, we had a problem 1-2 days with the systems, which makes a kind of unreliability for our very good system. So, can you explain what is the reality about this happening, apart from the conservation or other things?
All right, and, let's give them a chance to answer.
What's the next generation of satellites, because the others are preparing themselves?
Thank you. I think with Galileo, Jeremy, that would be
we start with this one.
Yes.
So indeed, there was in July an interruption of service for several days, and we have launched an investigation. At the moment when we speak, we know already everything what happened, and we have resolved the issue. And there were some problems that were identified, and what I can tell you is that this is taken very seriously, and everything is being put in place so that for the full operational capability, which is foreseen the year after, is going to not happen again. What happened is well understood and well under control.
All right, let's jump to the first question that we see here coming in through Slido. What is the vision of the European Commission about the connection with ESA, some typo, sharing roles, responsibilities? Would you like to answer? I think this would be at you.
Yes, so concerning this question about the connection with the European Space Agency, I think it is pretty easy. The European Space Agency has done marvelous work in developing the space sector in Europe. I mean, we have telecommunication satellites thanks to ESA. We have a satellite navigation system thanks to ESA. We have Earth observation data coming from ESA. EUMETSAT was created thanks to the work which has been done in ESA. So I see the role of ESA as an initiator of new technologies, new ideas, whether for Earth application or even for observing the universe, fundamental physics, etc. Where the, let's say, responsibility of ESA, I think, should stop is when we start to exploit the systems themselves, when we start to operate them, because it is not very natural for the European Space Agency to simply operate an operational system. I mean, it could be done by ESA, but it is not really in the genes of ESA. And I think this is a sort of practice which is now there since the last 30 years. Organizations have been created thanks to ESA to operate the objects and the infrastructures that have been put in place by the European Space Agency. So it's a very good organization to make breakthrough, to put in place new systems. That's how I see it.
Thank you. Thank you. Let's move on to something that has disappeared. No, there it is now. There it is again. Do you reckon that we need a co-program partnership on space within Horizon Europe? And if so, what is the added value vis-à-vis regular calls in the cluster on space? Anyone? Co-programmed partnership on space with Horizon Europe? No. Let's. Yep. You've got a microphone.
Oh, sorry.
Yes.
No, I mean, there have been discussions ongoing between the space agencies and the Commission on actually addressing certain specific space needs, space applications through Horizon Europe. And this is something that is very positive. Now, I know this might not be exactly the co-program partnership concept, but in a way, it is one step in some of those elements. Of course, then there's the bigger partnerships, of course, with the Commission being the owner of Copernicus and having the delegation agreements for the people who build, the people who operate the satellites. And of course, is again, a success story, I would say, on a European scale that is really welcome, at least from my side also.
Yeah. But as I said in my presentation, but I think it's applied to all space activity, compared to Horizon 2020, when we were more, I think, developing concepts, paper studies, or equipments, individual equipments, we want to go more live and to have in-orbit demonstration, large test beds, or measures that are really transversal, that will really, for instance, allow European industrial supply chain to be more autonomous, this kind of thing. So we see Horizon Europe will be really a very important tool for scaling up, basically, industry in Europe, in space.
And with 4 minutes to go, I think we certainly should have time for the highest ranked question right now. Copernicus is needing in situ observations for the services. How is the EU space program supporting them?
We perfectly recognize the importance of the in situ, as was done for the actual multi-annual financial framework and the regulation that defined the Copernicus program. In situ is a in-kind contribution from the member states. But we know that these in situ measurements are done by research infrastructure, and we have to support them. We are doing this through Horizon 2020 in the past. We are going to continue with Horizon Europe, but we really recognize the importance of this in situ research infrastructure, and I think that you can complement.
Also part of the point I was trying to make, that there's a lot of capacity that's going to fly in space where we don't know yet what will be measured exactly. I mean, we know how things will be measured, but we are not fully sure how this will be. And we have many cases in the past where new molecules were detected, things like this. And there is not necessarily an in situ component or even an in situ capacity that exists for some of those unknowns that we know will come. And this is where we hope that within the frame of R&D in Horizon Europe, that some of those more challenging elements will be addressed with the space component in sight as one of the potential long-term customers for such capacity.
Jumping to the second highest ranked question, what about space polluter pays principle, Guillermo?
Well, I think it's a good principle. Clearly, those decisions should be, we should reach a consensus between the various interested parties, because also the users clearly have got an interest in keeping, the environment sustainable and so on. But the important thing is to get all together and do something rather than, maybe pointing the fingers and so on. That is not really useful, because again, we all benefit. So hopefully we can get something done.
And then there's a question that I know is certainly sort of in quotation mark quite popular in the media. What about militarization of space? Is this a concern or an opportunity?
Well, clearly, my personal point of view is a concern, because clearly space is one of those places where actually even at the moment of big tensions, for example, between the US and Russia, the operations in the space station, everything was pretty relaxed, and actually is an area where there is a true global collaboration. So we should try to keep it that way, although clearly there are satellites that have got, military purposes and so on, okay? But let's try not to escalate this. Let's try to actually, if it's possible, minimize it.
It's 2 minutes and then the live stream ends, which means everything that happens afterwards is lost. But if one of you has a very short question that is not up here, now is the time for you to voice it.
So I will hook to what was said about the militarization. You have to keep in mind that not all EU member states have military. For example, I come from the island of Malta, which is also a member state, and in our constitution we have forbidden to have military alliances. Therefore, if the European program goes into the military action, it means it's going against our constitution. So, and in negotiation of the EU space package in the Council, which I happen also to follow, we have like special conditions for those member states I think there are another 3 member states that have neutrality in their constitution. And that sums up to the question on militarization. So we prefer to have a purely civilian program.
Okay, well, thank you very much for this comment. You can keep the microphone, because at this point I would like to wrap the discussion and also end this session. Thank you so much to our scientists, panelists here on stage. Thank you so much to Paul Flamand. Thank you for coming to Room 10 Pasteur, and I hope there was plenty of takeaway for you to move on as you enjoy, hopefully, the rest of the RNI days here in Brussels. Thank you so much.